Hi, I'm Eileen Bookestein. I'm the Education Coordinator for the Lower Grand River Organization of Watersheds. And I'm out here at Seidman Park today with my helper Jack, and we are looking at the water quality of Honey Creek and showing you how to use some of the equipment that you have in your H2OQ backpack and some of the additional equipment that you might have at your classroom or that you might have received as a participant in LGROW's Blue Crew water monitoring program. So earlier we looked at how to do chemical tests out of the backpack. Now we're going to focus in on some of the parameters that can be assessed using some relatively inexpensive but accurate technical equipment like meters and probes. So the first test we're going to do, I'm going to have Jack help me out, is pH and temperature. So pH is this red probe here. You can go ahead and grab that and turn it on. pH is a measure of how acidic or basic the water is. So most organisms have a very specific range that they need to be within to survive and to thrive. So generally, we would prefer a pH somewhere near 7, it's neutral. Michigan streams tend to be somewhere in the 7 to 9 range. So you're gonna go ahead and put your pH meter in the water. And this meter is reading both pH and temperature at the same time. So it takes a few seconds. Once the reading has stabilized, there's a little hourglass in the upper left corner that will disappear. And when that disappears, we'll have our pH and our temperature reading. So the hourglass has disappeared. Our pH reading is 8.3, which is pretty normal for a Michigan stream. That's good, that's in the good range. And our temperature is 12 degrees Celsius. Temperature is a really important factor because it also affects other parameters like dissolved oxygen, which we talked about earlier. Warmer water can't hold as much oxygen, colder water can hold more oxygen. And if we see big changes in temperature, that's an indication that there might be some kind of thermal pollution happening in our watershed. So we're going to take the temperature here, but when you're out sampling, you'll want to also take a temperature approximately a mile upstream of your sample site if possible, because we're going to look at the temperature change between the two sites to see whether or not something might be affecting the temperature there. So you can go ahead and turn the pH meter off. Just press the button to turn it off, put the lid back on. And the next parameter that we're going to look at that does have equipment for this in your H2OQ backpack is total dissolved solids. So that's this blue Primo meter here. So total dissolved solids gives us a sense for what types of materials are dissolved in the water. So sometimes we measure electrical conductivity. What this meter does is measure the electrical conductivity of the water and convert it to total dissolved solids. And that gets a sense for what types of minerals and other ions might be in the water. So all you have to do is press that button on top to turn it on, and then set it into the water. Make sure the water level is between the min and the max line. And again, you set it in there, you hold, it takes a few moments to kind of stabilize. This is also something that is calibrated based on temperature that happens automatically within the meter. So we've got a reading of 270 parts per million, which again, pretty average for Michigan streams. And the types of things that could be dissolved in the water include things like chlorides and other types of ions that might be washed in from the watershed. So this is one where around 2 to 500 is a pretty normal range for a Michigan stream. If you see a big spike in the number, that's an indication that there might be some kind of pollution. So you can go ahead and take that out. So these are the 2 meters that come with the H2OQ backpack. So if you have one of these backpacks, that's where you're going to find these meters. Now I'm going to show you a few other options because a lot of teachers in our watershed have access to some other resources at their chemistry lab at their school or through their local ISD. So for example, at the Kent ISD, you can check out some of these probes that I'm going to show you next. These are called vernier probes. This version is the GoPro version, which means that it can connect to a mobile device or a tablet or a computer via Bluetooth connection. So you can take your cell phone out in the field or your school tablet or a computer and connect that way. You can also use a USB cable to connect it if your Bluetooth device isn't working. So the way that these will work is you simply take the probe out of its container. This is just a storage container. This is a dissolved oxygen probe. I'm going to press and hold this button to turn it on. And then I have this connected to my laptop right now. So you'll need to use a program called Vernier Graphical Analysis, which you can download for free. And you click this button that says Sensor Data Collection. And what this does is it recognizes that there is something in the vicinity that it can connect to right here. This is our dissolved oxygen probe. I'll click on that, let it connect, and then it says sensor channel DO concentration. That's connected. I click done and it takes me to this graph screen. Jack, I'm going to give you the probe. This one, you just want to make sure that that metal line is in the water, and then I'm going to hit collect. Now these probes, you'll see the line, they take a continuous measurement. So you'll see this line start to travel across the screen. They take a moment to stabilize at the right temperature. They take a moment to stabilize at the right reading. And so you're just gonna wanna give it 30 seconds, a minute or so to get to a spot where the number is no longer changing. So you can watch it on the graph, and you can also see in the bottom right corner, it's giving us a numerical reading. So Jack, you're going to want to hold that just a little bit off the bottom. Excellent. And we can see this is stabilizing. It's getting pretty stable right around the 10 milligrams per liter of oxygen level, which is great news because when we did our chemical dissolved oxygen test, it was also 10 milligrams per liter. So we did a good job. Very good. So you can go ahead and take that one out and just set it down there on the table.
Alrighty.
Some other options for assessing dissolved oxygen. One of them is using another type of meter. If you don't have your own H2OQ backpack, you can borrow one from the Michigan Department of Environment, Great Lakes and Energy, EGLE. And if you do that, it comes with this meter. This is another type of dissolved oxygen meter. It just has a cord in it. You just turn it on. And just like the other one, this one is self-contained unit. So it reads right on the screen what your dissolved oxygen reading is. So you would take this, once it gets started up, you would set your probe into the water sample, and again, wait for the reading to stabilize. And again, it takes a few seconds. It's probably not going to stop at a certain number, but it will get to the point where it hovers around a certain area. And we're right around 9.9, which is right on track with our other samples that we took. So that's our dissolved oxygen reading. So if you are in Kent County, as an educator, you can check out from the Kent ISD a dissolved oxygen or a pH Vernier probe from the ISD. You can also purchase your own probes if you don't have them. So next, let's look at what the pH probe might look like here on the Vernier Graphical Analysis. So that one, just like the other, you're going to want to press the button to start it. So once you have been looking at one parameter, you can switch in the program off to another. Clicking this button in the lower right-hand corner that looks like a little sensor. It says Sensor Setup. So I'm going to go back. And I see, once he turned that on, a new sensor showed up down here. This is the pH sensor. So I'm going to click to connect that. And now I have pH set up. So that's going to take me to a graph. It's still looking at my dissolved oxygen here. So I'm going to turn dissolved oxygen off and turn pH on. And then once I hit collect, go ahead and stick it right in the water. You just want to make sure the bulb of that probe is under the water. And you can see it is starting to read the sample, and that number is changing a little bit over time as it begins to stabilize. The pH probe is the one of all the Vernier probes that requires that it's kept in an upright position in its storage container, because inside the pH storage container there's a storage solution that keeps the little bulb on the bottom moist. And if that dries out, your probe's not going to work. So make sure you store that one right side up once you put it away. So we can see our pH is still kind of stabilizing here. We're around the 7.7 range. It's going up a little bit. Looks like it will probably end up stabilizing around 8 like we got before. So you can go ahead and switch that one out. And then the other two probes that I'm really excited about, we just tried these ones out, are the nitrate and the chloride. So the nitrate probe is, as you saw in the chemical test, that's a test that takes a long time. If you don't have a lot of time to do that test, or you prefer to not do the color comparison, the nitrate probe is a great option. So if you want to turn that one on, we'll pop it in here. You see how easy it is. Yeah, they're hard to get out. I'll connect that probe. You can go ahead and stick it right in the water there. And then again, we'll change our graph over to looking at nitrate in milligrams per liter. So because there's a little storage solution on a sponge inside the storage container, a lot of times your initial reading will be a little high when it starts. So that's why it's really important to give it a few moments to stabilize so that it can go down and get to the actual solution sample in the water. So we're still going down. Right now I'm reading in the bottom corner, we're at about 2.5 milligrams per liter. It's going down a little bit. Sometimes it does help to kind of move it a little bit in the water. It just helps a little bit more water pass over the sensor and can sometimes get you to that stabilization point a little bit quicker. So what we're seeing is, well, you took it, yeah, there you go. We had a little spike there. You must have pulled it up out for a minute. So our nitrate is ending up down here right in the 2 range, which is right about what we found on our chemical test. So that's great news. So you can go ahead and take the nitrate out. Nitrate is one because nitrogen is one of the primary gases in the air. When you take it out and it goes up in the air, that number is going to go up. So just be aware of that. And then the final one that we're going to look at is the chloride meter. So you might have one of these little red chloride checkers in your backpack that was given to you as part of the Blue Crew program. Just so you know, these checkers are a low range checker. So they'll show chloride concentrations up to 20 parts per million. So chloride is something, think of where that might come from. Sodium chloride, road salts are primarily the sources of that. Michigan, because of our geology, has pretty high baseline levels of chloride. So sometimes this checker, it's really easy to get out of range above the 20 parts per million. So this one functions a lot like the phosphate checker that we looked at earlier. So I'm not going to demonstrate that, but just know if you have this, if your result is blinking at the end, that means it was out of range and your level is above 20 parts per million. So this is a situation where it'd be really great to have the chloride probe, because this will allow us to get a much better range of chloride in your system. So chlorides are, naturally occurring in the soil and in the water, but if we have too much chloride, too salty of water, you can go ahead and put that right in. Oops, I'm collecting nitrate. Let me go ahead and collect chloride. There we go. If we have too much chloride in the water, sorry, my thing is messed up. I gotta fix it a second. There we go. That's better. So chloride can be naturally occurring in the water and in the soil, but if we have too high of levels of it, essentially our water becomes salty. So freshwater organisms don't do well with a lot of salt in the water. And this is an emerging concern in water quality research, because there is, especially in areas like Michigan where it's cold and snowy, we have a high volume of salt that's put on the roads that can get washed into our streams. It's also interesting to use the chloride number in combination with our total dissolved solids, because our total dissolved solids and our electrical conductivity give us an understanding for the overall amount of ions in the water, whereas the chloride gives us a sense of one specific ion that you might see in the water, which helps you kind of tease out what's actually going on with your water quality. So I'm looking here, we're stabilizing a little bit. We're kind of in the 79-80 milligram per liter range on our sample of the chloride reading. So our little red checker wouldn't have been enough for this sample. So you can go ahead and stop that one. So these are all of the parameters that you can sample using meters and probes here in the Blue Crew water quality testing program. Don't forget to add this data to the data that you collect with your chemical sampling and upload it to LGROW's data map online so that other students and teachers around the watershed can compare their data to yours.